Discuss about network address translation NAT, how private networks communicate with internet. Today's agenda: what is NAT, why NAT is needed, how NAT works, type of NAT, port address translation, PAT, NAT table example, advantages and disadvantages, key takeaways. What is NAT? Network address translation NAT. It is a method of mapping private IP addresses into public IP address. It's operate layer 3. We call that routing or a firewall level. So it allows multiple devices on a private network share a single public IP address defined in RFC 1631 and RFC 3022. Essential for IPv4 address conservation, act as a boundary between internal and external networks. Why NAT is needed? As you know, so IPv4 addresses exhaustion. Basically, we have a limited number of IP addresses available for the use. So therefore, we will be using NAT. Organizations need more internal devices than available public IP addresses. Security hides the internal network structure from the internet. Cost saving, basically we will be having few public IP addresses to purchase. Cost saving, basically we need to have only few public IP addresses to purchase. Flexibility, internal addresses can change without affecting to the external connectivity. Enables private IP address ranges. So as you know that, so we are having private IP address range starting with 10.0.0.0 to 10.255.255.255, 172.16.0.0 to 172.31.255.255, and 192.168.0.0 to 192.168.255.255. How NAT works? So if you can see the below diagram, we have private IP addresses. So for device A, we have assigned 192.168.1.10, device B 192.168.1.11, and device C 192.168.1.12. So it's connecting to the router or a firewall. That is the device. We will translate the private IP address into the public IP address. Basically, device A translates to the public IP address. So 203.1.113.5. So that is a public IP address. So here, so you can see the source NAT. So this is the source 192.168.1.10 translate by router or a firewall. So then it's going to the public IP address 203.0.113.5 from the external. So we can see this IP address, not the internal IP address. So even here, so device B, so we will be using the same IP address. So source IP address is changed, but the public IP address will be remaining same. So for the device C 192.168.1.12, so it will translate by the router or a firewall. So then it will communicate through 203.0.113.5. So that is the public IP address for the entire private network. This is the source IP address. This is the destination NAT inbound. So public IP address converts to the private IP address. So basically from the external trying to reach out this IP address, so it will reach out to either one of devices. So we will discuss about in next slide. Type of NAT. So we have three type of NATs. Static NAT, it is one-to-one map. Dynamic NAT, one-to-many. PAT called NAT overload, many-to-one. When we talk about static NAT, it's a one-to-one map. One private IP maps to the one public IP permanently, used for servers needs consistent external accesses. For example, web servers, email servers. So we will be having one public IP address, one private IP address. So that is one-to-one map. Other one is dynamic NAT, many or else private IPs mapped to a pool of public IP addresses, first come first serve basis. Mapping is temporary. Assume that you are having network 172.16.1.0/24, 172.16.2.0/24, etc. Those two networks you will be having around 500 IPs, private IPs to assign to the device. But from the other hand, you will be having only few public IP addresses will be netted to the public IP address range, PAT or else NAT overload, many to one, multiple private IP addresses shared one public IP using a different port number. Most common types, it will be home or office communications. We will discuss about this more. PAT, port address translation. So if you can see the below diagram, private IP address, this is the source. So device A having IP address 192.168.1.10, then its port number 3000. So this is the layer 3 device router, it's do the net. So basically it do the port address translation. Port 3000 will be translated to port 40001. So then the public IP address will be 203.0.113.5, the port number 40001. Inside device A communicate through this communication line. The device B want to connect into the internet will be having the source IP address 192.168.1.11 port 4000, and using layer 3 device it will be net port 40002. So then the public IP address will be 203.0.113.5 colon 40002. The same, so device C 192.168.1.12 port 5000, so it will be netted to the port 40003. So then the public IP address will be 203.1.0.203.0.113.5 colon 40003. All three devices share one public IP address with a different port number. So here we will be discussing about net translation table. This is the private IP address, this is the public IP address, and here you can see the outside global protocol and status. Private IP address 192.168.1.10 port 3000. So it will be net with inside public IP address 203.0.113.5 colon 40001. So it will be going to the destination. It's 8.8.8.8 colon 443. Protocol is TCP. Then the second device private IP address 192.168.1.11 colon 4000 port number. Then it's inside public IP address 203.0.113.5 colon 40002, that is the port number. It's going to the destination 142.250.80.46 colon port number 80, protocol TCP. Third device private IP address 192.168.1.12 colon 5000 port number. So inside public IP address 203.0.113.5 colon 40003, this is the port number. So it's going to the destination 151.101.1.69 colon 443, this is the port number. Then the fourth device, fourth one, private IP address 192.168.1.10 3500 port number. So if you can see here, the same device will be sending multiple requests for the multiple destinations. So yes, in that case it will be used the different port number. Here the 192.168.1.10 colon 3500, the source port number. Then public IP address 203.0.113.5 colon 40003. So then it's going to the destination 52.94.236.248.443. Protocol is TCP. In this example, so you can see the same internal private IP address, but it will be different port numbers. So here is the port number, same device with port number 3000. Here it's at 3500, but the public IP address it will be the same, right? So the 203.0.113.5 colon 40001, this is the first request inside public IP address and the port number. Then this is the second request from the same device, but the second request you can see the different port number. There are two destinations. So NAT tables track all the active translations to route the traffic correctly. Basically every NAT device will be have NAT translation table. So it will be each entry maps internal source to the external representation used in the internet. Here I will be discussing about advantages and disadvantages. Advantages: we will be saving IPv4 public IP addresses. It will be providing more security. It will hide the internal networks to the outside world using this NAT translation. Other one is allows flexible internal address translation, reduce cost. Few public IP addresses, we can serve many private IP addresses. So it will be enables network remembering without external impact, and it is very simple to implement. When we talk about disadvantages, it breaks the end-to-end connectivity principles, complicates peer-to-peer applications, adds processing overhead. It might cause some issues, some with some protocols, for example, FTP, SIP, IPsec tunnels, etc. Make troubleshooting more complex and not needed with IPv6 addresses, but still used. So let's see what are the key takeaways. NAT translate private IPs to public IPs at layer 3 level. PAT or else NAT overload is the most common type used nearly every home office environment. NAT conserves IPv4 addresses and adds layer of security. Understanding NAT is essential for network troubleshooting. IPv6 reduces the needs for the NAT but doesn't eliminate it entirely. Thank you. Learn, build, grow beyond the rack.